Hi everyone. So I have a very long video that I just took, and I realized by the time I got to the end of it, I made it's perhaps a problem that's too large, although it does cover how we debug, my thought process on how I go about designing new code, how I can reason about and figure out what my bug errors in my code are. It looks at a variety of cin, cout, and string methods in order to accomplish the task. It's covering all the different parts about strings that I wanted to cover, but my goodness, it's a long video. So I'm leaving this as an optional video for you guys to look at. It's showing me tripping up and falling in all sorts of wonderful, wild ways, but I have a sneaky feeling that it's way more convoluted in terms of an example than what you guys need. If you are just trying to get your feet wet, it is not the example to follow because it will be too convoluting. So I'm going to take a simpler approach, but I have left the original code. Here it is. So it doesn't seem like that long of code until, I sit down and think about it. Wait, I don't think people that are just starting to program are going to necessarily understand exactly what I'm trying to do here. So I left it there so you have an example so you can look at it, but let's do a simpler set of tests. So the simpler set of tests, I'm going to write some new code. I'm going to have a string to test. I'm going to have a character string a to test too. Just this is going to be a character string. This is a normal string. The object version or the C++ version or way of dealing with strings, and this is our old way of dealing with strings. So I'm going to do a couple of different things. First of all, I'm going to get input and output. So we have the old way and the new way. Then after that point in time, then I'm going to look at specific functions for strings that we've looked at before and what the equivalents, some of the equivalents are in for the string class. And then afterwards, I'm going to duplicate the message and print that out again. So whatever I typed in, I'm going to make it twice as large. Now, you'll notice this is just a character array. A2test2 is a character array, and it has its size, string buffer size. That's actually defined way up here as a constant. Why didn't I just put the number 30 in? Well, you'll see other examples or other times when I needed it, but I might not want to just put the number 30 in here because later on, if I want to make this 45 and I have 10 different things all pointing, using the number 30, I don't want to, or maybe one of them is 30 and I needed a 20, I needed 10 less. Well, the better thing to do would instead of be I would if I'm hard coding in numbers, I might have written down 20. I want to make sure that if I need to change that number, I change it once and everything is reflected everywhere else. That I'm not hard coding in a whole bunch of different values that may or may not be, I may have to change later on. If I want to change this to 45, I want all my code to just work. So that's why we can sometimes use constants. Constants don't count like variables, as in, I'm not allowed to change this later. Notice it's all caps to indicate that it is a constant. Since I'm not allowed to ever change that, I can make an array of that size. I can't make an array of a variable size, but I can make an array of a constant integer size because it's never going to change. Okay, so it's the exact same thing as typing the number 30, but if I change this value later, it gets reflected everywhere. Okay, so let's do a couple things. Let's do the old way. So, old way. And so let's do some printf scanf stuff. So, printf, write a single word message. I'm going to make it a new line. I'm going to put a semicolon at the end. I'm going to do scanf. It has to be the safe version of scanf. And I always forget what scanf's syntax is. I know I'm going to need to do something like I'm going to need to say what is going to go into this. It's going to be a string. I'm going to need to, I think I'm going to need to put where this thing is going. Whatever I type in, it's going to go in there. Normally, if it was going to an integer, I would put like a star, an ampersand, not the star, an ampersand in there to make it a pointer. But because it is a character string. It actually is a pointer. It points to this big chunk of memory. And scanf underscore s has another little quirky part. It has a maximum size. It should have a maximum size. Now I want to double check all of this stuff afterwards, but let's put it in there for right now. So I want to and then we're going to do, I want to see what the heck I wrote. You wrote this, just so I can reflect and see what I have in here. Make sure it worked correctly. Okay, that is the old way of doing things. I'm going to compile it, see what my code does, see if it works. All right, so I should be able to, it should print out a message. I type in some other new string. It'll say what the new string is because it's being stored in this variable. So I type hello. You wrote hello. Great. That's sort of what I want. I want to make sure that this is working correctly before I move on. So I do a little bit of code and stop. I'm going to check out the new way. So let's do a new way. And we're going to comment out the new way and the old way in between. Here would be the new way. I'm going to see out. Notice the arrows go towards the see out. It is directional. They're directional arrows. It's where this thing is going. It's going out to the screen. Therefore, the arrows are pointing out to the see out. And I'm going to say, write a single word message. Again, if I wanted multiple words, I might have to use get line, or I might have to use get s for it. In the case of instead of instead of scanf, it would be get s, right? We have other functions if we need multiple words in a row, but cin and scanf will only take up to the next white space. So if I'm trying to type more than one word, I'm going to have a problem. Okay, write a single word message. I also want to make sure I put it, the standard is instead of using this /n anymore, I can still use the /n, but I often will write end line, end l, just to make sure that it's the right format. So this thing, this first message will go into the cout, and then after that, once that's resolved, then the end line will be attached to the end of the cout. That's how that's going to work. I'm going to have a cin. It's going to go into the cin. I need to test, and that should do it. And if I could spell, that would be awesome. Wrote, and instead of doing these fancy percentage s things, I'm just going to write to test. You wrote to test, and l. All right, and I want to make sure that's going to work. So let's see what we have here. Write a single word. Hello. Goodbye. You wrote goodbye. It's working exactly the same as the old way, except for I'm using cout and cin statements. A lot of people find this more intuitive, but there's some magic. Where the heck is this cout coming from? It doesn't look like any other functions we dealt with. This is actually working very much like 4 plus 3, right? It is, I have some operator between the cout and the string that's going there. Same as I have some operator between the 4 and the 3. I just have an operator. That's what this thing here is. This is an object that when we talk about objects, it's a globally visible object, but it's an object. Oh, I should also point out something else. Let's break my code. So I'm going to include the IO stream. That's what I need for cin and cout. I'm also going to just comment out this and see what happens. I should break a whole lot of stuff. Boom. A whole lot of stuff breaks. Let's look at what broke. Where the hell is the word string? Well, it turns out if I'm not using the standard namespace, saying that using the standard namespace says, by the way, when you're looking up the names of things, this is a good place to look, right? If you, it's a sort of a standard place to always search. If I don't know where something is, I look in the closet to see where things are, right? I've identified the standard place where I'm going to be looking, it's the standard namespace. I'm using the standard namespace. So if I see the word string, I'm looking in the standard namespace to see if that's defined there. If I don't have this, I may have to do this, std colon colon, and that should get rid of this. I would have to do std colon colon here, and here, and here, and everywhere I have string or cout and all of this stuff, I would need to put that std colon colon saying, by the way, go to the standard namespace, look for a string. That's what that's saying. In this special library that we have, go look for string. But I don't want to do this because I am lazy. So let's put back in using the standard namespace, and everything should fix. Well, almost everything. Let's see what this is. I have a cout statement just because I have that 4 plus 3. Problem with my cout statement. Okay, so I've gotten input and output. I want to process the string to find a specific character. So I'm going to look for the character E each time. Why? Just because. So, and maybe I want to find the, well, let's see what I have. strchr. Let's find the character E in this character string. So a to test 2, and the value I'm looking for is a character E. This is what we did last time. I'm looking for the first instance of that particular character, and it's going to return all right, the pointer to where that character is in the string. So then I could do a print statement. The E is at, and I'm going to put these special quotes. If I need to put a quote in my text, I can actually just put a slash and a quote. All right, I'm going to put that there, and I'm going to say percentage %s. I'm going to put that in between these two quotes. So the E is at in this quote, and then I'm going to, p message at E. So this is going to be the E is at, and then the message at the location where that E is located. Okay, hopefully that makes a bit of sense. Let's do the same thing over here. But instead of all of that, I want to use the string functions. So here's what I'm going to do. I'm going to take toTest. It is a string. I'm going to use toTest's the string's own function. I'm going to ask the string, hey, can you find the letter E in here? So find, and I could say, what am I finding? I am finding this particular character, E. Do I need to, and I have a bunch of options for this thing. In fact, I have 4 different ways of calling this function. I could call it with just with a character I'm looking for and the size of the offset, as in start at position 5. I might have a version where I pass in a character pointer for the string that I'm finding and an offset for the position. I may have a character pointer and a string offset and the size of the number of characters I'm going to be counting, how far I'm going to count, and I might have a string and the size of the offset. There's 4 different ways of doing this. I can be looking for another string, I can be looking for a character string, or I can be looking just for a single character. I'm looking for a single character here. I can also leave off where it's going to start and it would still work. Or I can put in what my offset is and say 0, right? That's an optional. Here it's saying there is an optional parameter. If I don't put anything in, it's going to default to 0. That's what this little pop-up here is saying. Or I could just say, yeah, explicitly, it's going to start at position 0. That's where I'm going to start looking for this character. Okay, what does this thing return? I'm going to hover over it again, and there we go. And it's going to return a size. What the heck? Pause. It's going to return the position where this E is located. So I'm going to say on pause. Now, this is just going to give me a number. I can convert that to a pointer to my string if I wanted to, or do some other things like that. So let's also do that. Let's make a substring. So string e pause text. I'm also going to change this. So I'm going to use the cout statements again. Cout e is at, I don't need that percentage I, e pause. I need to end my quote. And then and then I'm going to have this string pause. Notice I am essentially composing my text string by hooking parts together. I have a piece of text, then I have a number, then I have another piece of text, then I'm going to have another piece of text. I string these together and it forms the message that's going to go out. Okay, I need e pause text, which is equal to test dot substring. The substring is a part of my string. So substring, I can say where the offset is and e pause, and I don't need to put anything else afterwards. I could say I want the substring to the very end. Ooh, so if I leave it blank, it'll go give me the substring all the way to the very end of the text message. Or maybe I only want the first three characters after that substring. That would be three characters starting at position e pause. So that would only give me the three characters afterwards. You can play around with most of this stuff and get what you're looking for. And if you don't know, try it out. See what you get. Okay. Or e pause text and L. All right. So this will print out a message about that. I don't have a parentheses up there. That should work. And then after that, we'll look at one more thing we have to do. We're going to be doubling up our text message. The weird thing is, when we double up our text message, hopefully it's going to be a lot easier with the string class. And we'll see why in a second. So let's find, hopefully this is going to work. So write a text message, hello. You write hello. The E is at hello. Write a single word message. Oh, I should have put a new line in there. I'm going to use hello again. You wrote hello. The E is at position 1 or hello. So let's put those quotes back in there as well. But so far that actually worked quite well. The E is at, and then I'm going to use and put a new line in here. The E is at, so I'm going to put one of those in here. I'm going to put one of those quotes around the whole thing. Great. Now I want to do one more thing. It's going to work just fine the first time, but it's not going to really work this next time. So what am I going to do? I'm going to I can make a brand new buffer and copy everything over. That might work quite nicely. So let's do that. So I'm going to make a brand new buffer, a double text, and that's going to be, I'm going to make it the same size as the last time, just because, 30 is pretty big. Okay, is equal, and then we're going to just set it as that. I'm going to say strcpy. I'm going to copy, and let's do the safe version of it. I'm going to copy my string, and I got to figure out what the syntax here is. It's going to go to the I have the string copy. It's going to the destination from that particular source, and there's a size in the middle, the size value that I need to put in the middle. Okay, that should work for me. So I need the destination, a double text. I need the size of, so this is going, let's just save the size of my text just to keep it in as one variable. Old text size, which is equal to strlen of my thing that I'm going to be copying. So a to test 2. This is the length of a to test 2. I'm going to copy all of that over. And oh, that's the third parameter. Oh, and then I need to add the old. Oh no, I did do that. Okay, old text size, and then the thing I'm going to copy over A2 test 2. Notice this is not going to give me all of the characters. For hello, it'd be HELLO, 5 characters. The old text size is 5. The actual string has 5 characters and then has a 0 at the end. There's a sixth one. I'm only copying over 5 of them. So that's what this is actually one of the bugs I found out in the really long video, or the bug I created in the very long video. It's going to copy this number of characters. Irrespective of what this thing has, it's going to copy over that many characters, which is what led to some weird quirky problems happening. Okay, and I want to double it, so I'm going to offset. I'm going to change my offset where the double text starts. I'm going to move. So I'm going to take this. I'm going to plus old text size. That's going to move my pointer position over that many spaces. So where the new text, the second copy of the text goes, is going to be immediately after the first set. I'm going to copy over all of this text, but I'm also going to do +1. The reason I'm doing that +1 is I want to also include that 0 at the end. Okay, so this should copy over the first part of the text and then copy over the next part of the text. And so I should have hello, hello, for example. And then let's actually do a print statement. Printf, the doubled text is, and it's going to be hello, hello. Oh, let's put the string and line. I can put the quotes in there again. Okay, and I need to put in what my double text is. A double text. Okay, semicolon at the end. Okay, let's do it the other. Well, actually, let's test this. That'd be a much smarter move. And I probably should have even more uh, messages and comments in there. Write a single word message. Hello again. All right. Oh, we got an assertion fail. What is that assertion failure? Let's find out. I got an assertion failure triggering a breakpoint. Ah, this message here that's being transferred over is too small for what I'm actually going to be transferring over. Let's do the +1. I'm trying to transfer the entire message over. So +1, that should do it. It's giving me assertion failure because it's saying, hey, you're only allowed to move old text size number of characters. You're moving that many over. Well, let's move old text size +1, including the 0, and then just, don't move it all the way to the 0 afterwards. Let's also put a breakpoint in here to see what happens. Hello. Hello. All right. We're at our breakpoint. Our string buffer is currently empty. We are going to get the length of our string buffer and look at what this thing is. The old text size is 5, right? It's hello, but there's a hidden 0 at the end. I'm going to copy 6 characters over from this to this. Let's look at a double text. Hey, it says hello now, right? There's an implied 0 at the end. I might be able to even look at it. There it is, the implied 0 at the end. Okay. Next, I want to shift this thing over. So I'm going to, the starting position is going to be wherever the starting position is going to be right here. That's what 5 plus whatever my pointer is. A double text plus 5 puts me right here on this line, at this where this 0 is. That's where I'm going to transfer over this message over into it. So let's see it in action, hopefully. All right, and then my message is hello, hello, exactly what I wanted it to be. And the double text is hello, hello, which is what the message should be. Great. And that's going to be the end of my message, or the end of my program, is hello, hello. I put extra space around the quotes, but that's fine. Okay, you might wonder what, okay, that's fine, fairly simple. The other example was way more convoluted. What's it going to look like for the other case? So let's do this. I could either just do a cout, but let's do string double text and 2 is equal to, and I have what's my original message? It is to test. There you go. And done. Cout, the doubled text is, and I want to put that quote around there. I want to put that quote in there. I just put some exclamation points just for fun. And line. Okay. All right, and I'm just going to continue, get rid of the breakpoint. And let's look at what I have. The double text is hello, hello. The double text is hello, hello. Wait a second. It did the exact same thing. All I needed to do was a plus. Instead of doing all this crazy pointer arithmetic, just doing a plus. Some of these built-in functions may actually be better than what I had before. I have concatenate, I have find, I have substring, I have a bunch of functions that I didn't have before, or I didn't know the name of it. And if I don't know the name of a function, one of the great things about this is, to test, how do I find something? Well, there's find. Let's assign something. Let's append something. Let's figure out where something is, where something is at, right? Well, I want to get the back of my string. What's the capacity of my string, right? Where does it clear? Let's clear my string. Let's compare two things on my string. Let's copy. If you don't know where something is, put a dot, see what the options are, right? Can I erase things? Can I find something? Find first not of. The first one that is not of this type, right? Can I get the front of my string, right? There's all sorts of things. Too many things, if you will. Okay, let's do one more thing. Let's break stuff because it's fun to break stuff. So I'm not going to do hello anymore. Let's do blah, 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 blah. All right, good. Crap. Right. So unhandled exception. There's an exception out of memory range. So what happened there? You wrote, okay, there's a bunch of problems that happened there. You wrote, okay, that's well beyond what I actually what I wrote was way longer than that. Yeah, that's a problem. It actually is too big for what I have it is too big for what I have there. So let's I'm really surprised that this thing just allowed me to go that far. But if I'm trying to put something in this string, oh, there you go. It's a limited buffer size, so it will only take in those first number of characters. That's going to be my problem. So let's take in those strings, and I don't know why it would have that error in there then. I'm kind of curious. I think it actually recovered from what I had. So let's try it again. Let's do that. Okay. Uh, and you wrote this. E is that there is no E there at all? Really? Okay. There is no E there, so that's fine. Write a single message. E. Uh, and hopefully, do I have an exception thrown? I have an exception thrown. What's going on here? Let's look at my call stack. I can see what's going on here. Here's my main method. I'm at that particular line, and I need to figure out what double text is that. This is actually kind of interesting. string character. Let's actually put a breakpoint here and see what happens. Let's try it again. Okay, and I'm going to put another breakpoint down here just to make sure that we hit it. All right, the E I can tell, hopefully see where the position of the E is. The E is at position 8. Great, so that worked fairly well. E is at position 8, and then we're going to look at some other stuff here. We're going to make a double text. We're going to copy everything over from the string length over to this new text buffer, and now you're going to see where this is actually what the problem was that I couldn't track down. The old text length is size 24. How big is my array? If I have a big long message, 24 characters is not that much. If I have a big message like 24 instead of 30, I have maximum is 30. So it's in the acceptable range of the length even. But even if it wasn't, I'd have other problems. I'm going to copy the first chunk of text over to it. Then I'm going to copy the same text over, but 24 spaces deep into my array. What it's going to do is it's going to overflow. It's going to go past the end of my 30 characters that I gave for my array for this character array and blow up. It's the worst possible. This is a dumb move on my part, but you could do it. It's easy enough to do. Now, if I made the string buffer twice that size, this double string buffer, the problem goes away. But you don't know what you're going to be getting. One of the problems with character strings is if you run out of space for this thing, the whole thing explodes on you. You have to handle all these weird cases of, oh, what if the string is too long? What if this happens? What if that happens? Now we'll also look at, so I'm going to stop my program now because I'm pretty positive that's what's going to be my problem. Even if I get a weird error further down, it's due to this. I'm stomping on data that's not my data, has nothing to do with that particular array. I have no idea what I'm stomping on. It's something in my data. And it could be corrupting my string, for example. It could be corrupting any number of other stuff, any other piece of data that I have. So let's kill this off. Let's double the size of my double array, just because it'll make sure that I'm safe. Okay, and then after all this, hopefully, well, that's where I'm hoping here. Hopefully, the code is just going to work. So, all right, and I'm going to continue again. Just some random text. And I wrote that, and let's see what I have here. So, I'm going to double my string so the E position, we'll find the E position easily enough, hopefully. I'm going to get the string length of the things I'm looking for. It's 25 now. And I'm going to, so old text size is 25. I'm going to double it. This is twice the size, so this is size 60. This double text array is size 60 now. So we're safe in that respect. And hopefully so the next two should be fine. I should be printing off a very, very large text message. Yeah, there you go. Pretty darn large text message. Okay. And then I'm going to see what this thing does. Double text, I didn't do anything to my string at all. Hey, it works. Double text is, hey, it works. Perfectly fine. Because strings are a class, they know how to handle when you have too many characters in there, or they know how to handle how to reallocate memory, or whatever it needs. You can hide all of those ooey gooey gory details away from the user. And some people don't like that idea. But in many cases, it's saving you a lot of mental brain power by not having to worry about, oh, what if I run out of space in my array? And so this would be yet another reason for using a string object. It's also just laziness. Put a dot, find out what the function is. So this shows you a couple ways of dealing with strings. We dealt with even substrings a little bit. We figured out the length of a string using string length. Oh, did I use string length to do this? No, I didn't even need string length for this one. Let's do the string length anyways. And second strlen is equal to test.length. Now there's two different versions of length. That is a variable versus this is a function. Functions always have parentheses afterwards. Done. I now get the length of my string. I don't have to do anything special. In fact, I don't have to remember, is it called strlen? Is it called string length? What is it called? Right? The dot, and I can look up what it does. Okay. If you want to look at the more convoluted, and this is the simple version of the code. If you want to look at the more convoluted of the version of the code, where I am doing a string substring replacement in two different versions, please go right ahead and look at that. After this, we're going to go back to objects, and we're going to look at why we deal with objects, what objects are. Like this string here, this string has both data associated with the array, the characters that we're storing, and also a bunch of functions that are automatically wrapped up and carried around with it. And so we're going to look at objects and why they're important next class. Okay? Thank you very much, and hopefully this will be made some sense.